Hi there, welcome to my tutorial on completing the square. I want to look at three things today. I want to look at how we can use completing the square to write an expression in a factorized format. I want to look at how to use completing the square to solve a quadratic equation, and I also want to look at how we can use completing the square to help us sketch the graph of an equation. So first off then, I want to have a look at these three expressions here, and I just want us to look at how we'd factorize them normally. So if we have a look at this first one here, if I'm going to factorize that, I'm going to put it into double brackets, and I'm going to have here x and x. I need two numbers that multiply to give 3 and add to give 4. So I'm going to have x plus 1 and x plus 3. 1 times 3 gives us 3, 1 add 3 gives us 4. So I've factorised that expression. This one here, I want to solve it. I want to solve this equation. I've already factorised this part, so I know that x plus 1, x plus 3 is going to equal to 0. So now I'm going to take the x plus 1 equal to 0 and the x plus 3 equal to 0. So my values for x are going to be -1 and -3. Now that's going to help us if I want to sketch a graph. I've got the equation here, y equals x squared plus 4x plus 3. I've set the y equal to 0 so I can find the roots of this equation. So I know that the roots of this are -1 and -3. I could plot them on a set of axes here. So I could put those on and have their -1 and -3 as my roots. I also know that with this graph, the y-intercept is 3. So I could position that here at 3, and I can do a reasonable sketch of this graph. Cuts it there at 3. We know it's a parabola because it's a quadratic graph, so I can sketch my graph. What I want to do now is look at this expression here, x squared plus 8x, and I'm going to complete the square on this expression. So I'm going to do this normally. I'm going to factorise this normally first of all. I could have done just taken the x out, and I can have x times x is x squared plus 8, and I can factorise that normally. I could then do the same as what I did on the first expression there to get my x values for x equals 0 and x equals -8. I also know that it cuts the y-axis at 0, so I've got my roots 0 and -8. I could put those roots into here, -8 and 0, and I could sketch my curve. What I don't know though is I don't know the vertex of this curve. Same with this one, I didn't know this lowest point, the minimum point on my curve there. I want to show you how by completing the square we can work that out. So let's have a look at this expression then, and I'm going to go through the process of completing the square. We're going to use a little bit of geometry here to help us. I've got a square, x squared, so I know the side of this is x, and the other side here is also x. I've then got my second term, 8x, here. Another block here, a rectangle, and I know that this is 8, and this is also x, so I can add them together. So I end up here with x squared plus 8x, shown there with these two blocks geometrically. Now what I'm going to do is I'm going to now take half of this 8 and I'm going to move it, I'm going to reposition it here. So I'm going to move this over and reposition it underneath my square. Now obviously what I should be able to see is this 8 now is no longer 8, I've halved it, so this is 4. This here is still x, but this length here is the other half of the 8, 4. So this way I've got x plus 4 along here. I've now also got x plus 4 along here. And what I'm going to do is I'm going to try writing my expression now as just x plus 4 times x plus 4. So I'm going to write it as x plus 4 squared. X plus 4 times x plus 4. Now if I multiply that out, let's see what we get. I'm going to multiply this out. So I'm going to have x plus 4 x plus 4, which is going to give me x squared plus 8x plus 16. And now I'm going to compare this result with my original expression here, x squared plus 8x, and see how it relates. Well, I can see here I've got this 16 on the end here. I haven't got that on this one. So it's not identical to my expression. So I know that I've got x plus 4 squared. That's not identical to that. It gives me a little bit more. It gives me 16 more added onto the end there. I can see that from this diagram here because I've got this bit missing. If I then fill that in, it's going to become a little square there. And look what I've done. I've done x plus 4 times x plus 4, which would initially give me the area of the whole of this shape. But I've got this little bit here missing. That bit, if we have a look, has got to be 4 by 4, which gives me 16. This 16 is missing. This is the 16 that we've got here. So we've actually put on this square too much. So we need to take that away. So if I then take this away, the 16 away, then I've completed the square, and this expression is identical to this because all I've done is taken the 16 away from x plus 4 squared. Now what we should be able to see here is that this 16 is, we get that by doing the 4 times the 4 squared. So I could replace this with negative 4 squared. Now what I can do is I can generalize this into a completing the square formula. What I'm going to do is, instead of having this as x plus 8x, I'm going to now call the 8b. So I've got my basic expression, x squared plus bx. I'm now going to write that in my completing the square format. And it becomes x plus, what did I do? I halved the value of b. So it becomes b divided by 2. I've halved it. And then I squared it. But then I took away b divided by 2 and squared it. So I took away b divided by 2, which was me 8 originally, which became 4, and I squared it. So in its general format, completing the square becomes x plus b over 2 squared minus b over 2 squared. Okay, now what I'm now going to do is I'm going to actually take my expression, x squared plus 8x, and I'm going to solve it. I'm going to complete the square, and then I'm going to solve it, and then I'm going to show you how that will help us to actually find the vertex, the minimum point of a curve. So let's just rub this out. Okay, now I'm going to solve this equation at the top here. So our equation we had was x squared plus 8x, and I'm going to set it equal to 0 now. Now I've completed the square on it. We did this below, and I got my answer of x plus 4 squared, take away 16. Now, because it's an equation, I can set that equal to 0. So now I'm going to solve it in the normal way. I'm going to take the 16 over, so I've got x plus 4 all squared equals 16. I'm now going to get rid of the squared and square root both sides, so that's going to give me x plus 4 equals plus or minus the root of 16. Remember, every root will have a positive and negative value, so I need my plus and minus in there. So now, if I take the 4 over, I get x equals negative 4, and then I'm going to have plus root 16, plus 4, but I'm also going to have x equals negative 4 minus 4. So my values I'm going to get are x equals 0 and x equals negative 8, which is exactly what I got earlier when I factorised it in a more traditional way. Now, I have now got two values, my roots here, which, if you remember, I positioned on these axes here. What I can also do, though, from completing the square, if I go back to this part here, I can use that to help me find the vertex, the minimum point of the curve. Now, what I'm going to do is, if I make function x equals x squared, my initial curve here is going to be y equals x squared, and I'm just going to sketch that on. So y equals x squared goes to 0. It looks like that. Now what I'm going to do is I'm going to carry out some transformations on this, because I got x plus 4 squared minus 16. Now I've already said that fx is going to equal x squared. So I'm going to carry out two transformations on this original curve here. The first one would be fx plus 4. The squared is already taken up here. So I'm going to carry out that transformation on my curve. Now this one here, fx plus 4, is going to be a translation. And it's inside the brackets. It tends to do the opposite to what you'd expect. So this one is going to move my curve 4 places to the left. So my curve's initially going to move to here. But then I've got another transformation here. I've got to carry out the fx minus 16. And minus 16 is a vertical translation. Does it doing what you'd expect it to do? It's going to move down the page, down the axis, by 16. So I've originally shifted my curve to here. I'm now going to carry out the second part of the transformation here, and I'm going to move it down the page to negative 16. So negative 6, negative 8, let's put a couple more on there, negative 12, and here negative 10, sorry, negative 12, negative 16 is down here. So my curve moves to there. That's my vertex. I still know that it cuts it at negative 8. That's my vertex, and it goes through 0. So my original curve, this curve here, y equals x squared plus 8x, can be shown by this curve here. I'm just going to finish off here by showing you how to complete the square to solve some quadratic equations here. First one, we've got x squared plus 10x minus 4 equals 0. So I'm going to complete the square on the x squared plus 10x, which gives me x, half of 10 is plus 5 squared. Take away half of 10 squared, so take away 5 squared, minus 4 equals 0. If I now tidy this up, x plus 5 all squared, take away 25, take away another 4 is negative 29 equals 0. If I then take the 29 over, x plus 5 all squared is going to equal positive 29. If I then take the squared, or square both sides, I end up with x plus 5 equals plus or minus the square root of 29. All that remains is for me to take the 5 over, to leave me with negative 5 plus or minus the square root of 29. I'm going to leave it in that format. Square root of 29 is obviously going to give us a decimal answer. It can't be rationalised, so it's best to leave it in exact format. Second one then, same process. I'm going to start off with x plus half of 12 is 6 squared, take away half of 12 squared, plus the 35 equals 0. I'm now going to tidy it up, so I get x plus 6 squared, take away 36, add 35, gives you negative 1 equals 0. If I then take this to the other side, I get x plus 6 all squared equals positive 1. So now x plus 6, when I square both sides, is going to equal plus or minus the square root of 1. So x is going to equal minus 6 plus 1, which is minus 5, or x is going to equal minus 6 minus 1, which is going to equal negative 7.